All right, so we're talking about x and y intercepts here. So x-intercepts are where your graph touches or crosses the x-axis. So when you look at this, you have one here, one here, one here, and one here. You have 4 spots that your graph touches or crosses the x-axis. So in order to list those, you're just going to list the values where that happens at. You can list them as ordered pairs. That would be the ordered pair 1, 0. Or you could just list them as an x-intercept as 1. You have this one right here, which is an x-intercept as 3. You have this one, which is an x-intercept of -2. And then that other one right here, which is an x-intercept of -4. So this particular graph has 4 x-intercepts. It can have as many x-intercepts as you can get it to have. Y-intercepts, on the other hand, you only get one of them. The reason you only get one of them is because it crosses, if it crosses that y-axis more than once, then it won't pass the vertical line test. If you remember, when we decided if something was a function, we would draw a vertical line through it, and if it touched only in one spot, then we knew it was a function. If it took more than one spot that it crossed, then it wasn't a function anymore. So these are functions, so they can only cross in one particular spot. So this one crosses at y equals -1, so my y-intercept would be -1. So another example here then, when we're doing our x and our y-intercepts, again our x is where it crosses the x-axis at, so here, here, and here. And so we can just list those numbers. That would be 4, 3, and -1 for our x-intercepts. And then when we do it for our y-intercepts, we're going to just go find where it crosses the y-axis at. So I think that's, yeah, 12 or 13, but I think I'm going to put 12 for that. Okay. One more problem here with this. So x-intercepts, what do you think? Anything crossing or touching the x-axis? Nope, so that's going to actually be undefined or no intercepts at all. Okay. And then the y-intercept, it's touching or crossing at y equals 2. So you can put y equals 2, you can just put the number 2 there. Okay, very last one, example here on the x and y intercepts here. So where does it cross the x-axis at? It actually crosses at x equals 0. Where does it cross the y-axis at? It crosses in the same spot, which would be y equals 0. This is actually, I want to point out right here, not a maximum or a minimum if we were looking at it, because our slope stays positive the whole time. This is a special point called a point of inflection, and we're going to talk about those later, but we're not going to necessarily talk about them today. All right, the next thing we have to do on here is we have to do the interval of increase and the interval of decrease, which is where we're going to look at the slope. So the slope of this line is positive right here. It starts positive, and then right here it changes to negative. Right here it changes back to positive. So our intervals of increase and decrease are exactly that. Where is my slope increasing? Where is my slope decreasing? So I'm going to look at the interval of increase first, and remember the intervals are left to right. So I'm looking at my x values to see. So how far to the left is this going to keep increasing? Now it's kind of looking like I'm going down and into negative infinity, right? Going that way. So, but I'm really looking at how far left my graph would go. And my left, how far left it goes is to negative infinity. So I know I'm going negative infinity on how far left that slope's going to be positive. Then how far right is it going to be positive? Well, it changes direction at x equals 2. So I know I'm going to have my interval stop at 2. I'm going to union that with the other spot that it has a positive or increased slope. So from here, which is 4, I also have increase. And then it is going to go forever to the right. So I'll stop my interval of increase at positive infinity. My interval of decrease is where my slope was negative, and I kind of have it marked here already for me. It starts at 2 and it ends at 4. So my interval of decrease will be 2, 4. On intervals of increase and decrease, we're almost always going to use parentheses. It's very rarely are we going to know exactly where we're at. Okay, so the very first thing to do to find increase and decrease is to mark the slope. So negative slope, negative slope, negative slope. Right here, it changes to positive. Then it changes back right here to negative, and then changes back to positive. So when we look at this, we're going to have two intervals of increase, because there's two sections where we have plus signs. We're going to have two intervals of decrease, because we have two sections that have minus signs. So intervals of increase, we start where our plus signs start, which is right here at 1. And then we go to where our plus signs stop, which is right here at 2. We're going to union that with our other interval of increase. It starts at 3 and goes to forever to the right because of the arrow sign that's going to keep going to the right. The interval of decrease, on the other hand, is going to start forever to the left, which would be negative infinity. It stops here at 1, and we're going to union that with our other interval of decrease, which is in between right here, which is from the number 2 to the number 3. So again, interval of increase and decrease, we find our plus and our minus signs for recognizing the slope, and then just write the interval where those things are happening. Alright, so here we go. Let's mark it with our positive and negative slope. This is positive slope, positive slope, positive slope, positive slope, positive slope. It's all positive slope. So there's not going to be an interval of decrease, right?
So you put the...
Yeah, the empty set. Yeah, the no solution sign. And then interval of increase, then, this is going to go forever to the left, and this is going to go forever to the right. So my interval of increase would be negative infinity to positive infinity, because it goes forever left and forever right. All right, I think we have one more here. Okay, mark it with plus and minuses. So plus, 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 minus, 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 plus, plus, plus. So this has two intervals of increase and only one of decrease. So how far to the left is it increasing? Well, it goes forever to the left, so negative infinity. And then it stops at, we're going to have to kind of pick a number in between there. So I'm just going to pick an easy one like negative 2.5. And then we're going to union that with our other interval of increase that starts at, should we just say 0 to make it easy? And then it goes to positive infinity. Then we'll just do our interval of decrease, which was in between. Because I used negative 2.5 up there, I'm going to use that same value down here. I start at negative 2.5, and I stop at 0 for my interval of decrease, where my slope is negative.